What we can do is link these ideas of sets and these Venn diagrams to talking about cardinality, which essentially takes those areas that we were talking about in the pictures, or even those descriptions of the sets, and changing them to a number. And the number that we're specifically looking at is describing the number of elements in those sets. So in that first video where I talked about that set of fruit, I had apples, oranges, and bananas, and I believe I called that set B for, I think I was talking about a basket. F would have made sense for fruit, but let's go back to B. What we could do is talk about the cardinality of that group, like how many items are in that group. So for notation, to talk about cardinality, we use this, and it's like function notation. If you've used function notation before, like f of x, where we have this function of x. So it kind of looks like multiplying letters, but that's not what it is. It's a function notation. And the notation that we use specifically for cardinality is lowercase n. So this, how we would interpret this is just number of elements in set A. So if I have my basket of 3 pieces of fruit, and I wanted to talk about the cardinality of that basket of fruit, and it's kind of a small basket if it only has 3 pieces of fruit, but that cardinality would be 3. That set that I made up in that first one from rolling a die, so I had my sides 1 through 6. If I wanted to talk about the cardinality of that group, there were 6 possible outcomes, so that would be the cardinality. So it's taking a set and reducing it down to a number, just representing the number of elements in that group. So let's see how this can work together with our Venn diagrams. So what we're going to have here is a survey of 100 American workers. So that gives us an idea of our universal set. We have this overall 100 workers, and they're going to tell us how it divides up. But what I have an idea of so far for my Venn diagram is my universal set, which overall everything should add up to 100 when I get in there. So that's giving us this overall value. In fact, you could even write, in terms of notation, the cardinality of our universal set here for this question is 100. That's notation I could use there. We have 56 reported they have a workplace retirement plan. So I'm going to go ahead and use the letter R there. So what I have is this cardinality for a retirement plan. 56 people were in that group. Then they tell me about health insurance. So cardinality for health insurance is 68. Oops, got too close to the edge there. Sorry. Hold on a second. 68. And then they tell us about this number for having both, so a retirement plan and health insurance. And actually, that's, without even drawing a picture, that gets at our answer for this first piece here. So this is looking for the cardinality, so it wants to know number of people that have a retirement plan and at the same time have health insurance. So again, that intersection symbol you could think of as and, or you could think of it as both. So for that question, I'm not going to need to do any math. I don't even need to really draw my Venn diagram. It would be 49. And something we're going to do with these questions that we go through here, make a sentence answer. We have context here and information. And even though they're asking something of us in notation, let's go ahead and put in a full sentence of saying 49 of these American workers, just to show that we can interpret the notation that we're seeing there. So 49 of the American workers, and this idea of having both, so we could say have a workplace retirement plan and health insurance. So that would be a nice complete sentence using the cardinality, but then taking that notation they gave us and putting in words. Alright, so to go back to what's actually the first question in drawing the Venn diagram. So we're going to have this set for the retirement plan, we're going to have this set for health insurance, and something that we know is that they overlap with each other, because there are people that have both. So I'm going to draw my circle best I can for retirement plan and health insurance. Now, in plugging in numbers here and filling in numbers for blanks, because there's basically going to be 4 spots we're going to fill in. We're going to have a number here, a number here for the intersection of the two, a number here, and a number outside. So we want to fill in the blanks there. The best place to spot, especially in terms of the numbers they gave us, is with the intersection. That number for both. So we know there are 49 people in the middle there that have both the retirement plan and health insurance. So that's a good place to start, because when we start going to say here for retirement plan, something we need to keep in mind is that number that we're trying to find there, it's actually the people that have a retirement plan and at the same time don't have health insurance. So this 56 that they gave us, that's representing this entire circle here. This whole circle has a value of 56, and something we need to keep in mind is that 49 of them are taken up by that middle piece. So to get that spot for just retirement plan, kind of like retirement plan and at the same time no health insurance, what we could do is to think of the cardinality for that, is we have overall these 56 people, but take out that overlap of the 49. So we can figure out who just has a retirement plan, and that should be 7. Same thing for health insurance. If we want to look at this cardinality for having health insurance and at the same time they don't have a retirement plan, so what we'd want to do is overall for health insurance there were 68 people, but we needed to take out those 49 or they overlapped with each other. So with that, we need 19. And then our last one here is basically everything that's left over. So in terms of notation, what that would look like is, and I'll actually write it over here, it would be this cardinality for no retirement and at the same time no health insurance. So they don't have either. And what we could do is think about how there's overall 100 people answered, take out those 7 that only have a retirement plan, take out those 49 that have a retirement plan and health insurance, and take out those 19 that only have health insurance. And that should leave us with 25 left over. So then we have this great picture for all these different groups, these 4 different groups, and we can see overall the 100. This is something that we can see again with probability. Instead of talking about like the number of people in the retirement group, we can talk about the probability of being in the retirement group. A similar idea can come through when we get to probability. Okay, so with that picture, let's start answering some other questions. And we're going to see these rules come up that I put at the bottom here. I'm going to talk about something called the addition rule. And the addition rule comes up when we're looking at unions. And then we also have a rule for complements that we can talk about as well. Now with these rules, and we're going to see these rules again when we get to probability, it's very closely tied together. But there are ways around these rules. It's just if you need something to refer to, use these absolutely. But there are ways to get to the same answer, so I'll kind of show you maybe what looks like a more direct way to the answer, but then I'll show you applying the rule just so if you need to refer to it, or it's just sometimes you have to use the rule, you can't calculate it a different way. But alright, so this first one here, we're looking at a union. So we want to have retirement plan or health insurance, or both. So with calculations with or, you're generally using addition. Having one thing or the other ends up kind of adding things together. So the direct way to see this, without using the rule that's down below, the direct way to see this with the picture up above, again, in terms of what I want to calculate with this, in the picture, it's represented as this overall area. It would be retirement plan, or both, or health insurance. So what you could do is just add up those cardinalities. So take 7 plus 49 plus 19, which will be 75. So I could say 75 of the American workers have a retirement plan or health insurance. Sorry, I'm writing shorthand there just for the sake of time, but write those nice complete sentences on your written assignments and exams. Alright, so using the addition rule. So these rules can be nice when you don't have a Venn diagram to work from, though you can typically draw one, but using that addition rule down below. So what we would have here, if we're looking for this union of retirement plan or health insurance, and just to kind of show you why the rule's written this way, is if you think of addition, then what they say is, well, if you're looking for the union of these two groups, add them together. Take the number of people that have a retirement plan plus the number of people that have health insurance. So what that would look like in this case is 56 plus 68. However, and I'm going to need to fix this, so hopefully you're not writing in permanent pen if you're writing this down, but if I add those up, 56 plus 68, what you're going to see is 124. But we only surveyed 100 people. It's going too far. It's too large. So we need to adjust it. What essentially happened is by adding those two groups together, so I took everyone that has a retirement plan, so I took all 56 people that are in this group here, and then what we did is we added that together with everyone that has health insurance, so then I took all 68 people in this group. But what happens when we do that is we count some people too many times. Specifically, these 49 people right here. They got counted twice. So we took 56 plus 68, and when we did that, that group in the middle got double counted. So what we need to do is subtract that 49 out once, so that it's counted correctly. So then I'm really only shading once. So that's where you'll see in this rule down here of if we're looking for the union of two events, take one set plus the other set, but then we have to subtract where they intersect with each other. So for our example, we're going to subtract off that intersection of having a retirement plan and health insurance. So we need to subtract out that 49 to make up for it being counted twice. If we do that, the math works out correctly, and we'd get our 75 out. So that's the addition rule applied. It'll show up exactly the same when we get to probability, and we get to probability, it has a lot more application than here, where, as I showed with that first method of calculating it, you could see it a little more directly from the Venn diagram. Alright, our last one here is the complement rule. And I'll show you kind of the direct way to go about it, and it's probably going to look almost the same as we do down below. Alright, calculating the number of people that don't have a retirement plan. So what I could do here is kind of focus on who does have a retirement plan, and I just want not them. So I don't want to take those numbers that I just highlighted. I want everything outside, which would be that 19 or that 25. So what we could do is add those up to get our answer of 44. So we could say 44 of these American workers don't have a retirement plan. So, the actual complement rule, though, just so you can see how that applies here. So the complement rule says if we want to exclude an event, so if I want to find not retirement plan, what you can take is the cardinality of your universal set, so how many people are in your overall group, and then remove the cardinality of the event that you're trying to exclude. So what I'd essentially be doing here is take all 100 people that we surveyed and then remove those 56 people that said they had a retirement plan. So this can be helpful when you're working with a lot of different sets and maybe you're missing a lot of information. But if we had all of these different sets, but they said, hey, we talked to 100 people and 56 said they had a retirement plan, so how many don't have a retirement plan? Simple subtraction between those two numbers there, and you get the same answer out. So that one's nice in that it lets you deal with less pieces of the puzzle by getting to the direct complement. Alright, so those are two rules coming up, but again, you can use other methods to get to the same numbers when you have your full, complete Venn diagram. So let's look at a case where we actually are just going to deal with notation with this and not have a Venn diagram. What we're going to have is a total of 14 desserts. So that's going to be our universal value here. We have these 14 desserts. And actually, even without notation, I'm just going to put together some words here. So we have 14 desserts. 8 have ice cream as their main ingredient. 9 have fruit. Something you might notice here, so we have these 14 total desserts, 8 have ice cream, 9 have fruit. If you think about adding those up, we would be getting 17 out, which is more than our number of desserts. So that would be something that tells me that we can have both. It's possible to have ice cream and fruit in dessert. So what we're going to assume is that with these desserts, they have to have ice cream, they have to have fruit. So in terms of a picture, if we did kind of think about our Venn diagram here, I have all of these desserts, I have ice cream, I have fruit, and actually what would happen with this one, if I have all 14 desserts, I wouldn't actually have anything outside of that. These desserts, they have to have ice cream, they have to have fruit, or they have to have both. I know that all of those add up to 14. So what we could say here for notation, so the cardinality of my universal set is 14, but something special that's happening with this problem is that it isn't just the universal set. This picture that I drew here, if I wanted to think about like everything that's in each of those circles and even the overlap, that represents our union. So that 14, I could also write that as the union of ice cream, union, fruit. If I want to describe desserts that have ice cream or fruit or both, there are 14 of those. Then they tell us the cardinality for the ice cream group. There are 8 desserts with ice cream. And then for fruit, there were 9 desserts that have fruit. And what I want to do is figure out how many have both. Basically, what's the cardinality of that intersection there? So I want to find what is the cardinality for the intersection of ice cream and fruit. Now, the pieces coming through here, we have a union, we have kind of the single sets, and we don't know the intersection. Something that's going to relate these pieces to each other is that addition rule that we're talking about up here. We can see our union, the intersection, the individual values. Just be careful of, like up above there, we were solving for a union. In this case, we'll actually be solving for the intersection. But it's a formula, so we're just going to put the pieces in the correct spot. Just be really careful of, especially the notation for union and intersection looks so similar. Just take that extra pause and make sure you're plugging things in the correct spot. Meaning, what I could write out as a formula using that addition rule is that the union of the two is equal to the addition of the individual sets minus the intersection. So what I'd have here is there's 14, there's 8, there's 9, minus what we don't know. In this way, we can see exactly what I was saying in words at the beginning, that there are too many desserts if we just add those up. And you can even find this without the formula, just some thinking can get you to the same answer, but just for the mathematical proof of it, I can subtract 17 from both sides, which will give me a -3. And when you do this, just a little algebra review here. So 17 minus 17 turns into a 0. That subtraction's important. It carries a negative symbol then with the cardinality. But if you have something on one side of the equation that you want to make positive, like if I want my next step to have this positive cardinality, there's a few ways to think about it. Typically, I think of it as multiplying both sides by -1. You might even just think about, like, change the signs of both sides. But if we do that, that'll make our right side positive, and then our left side will also be positive. Cardinality should always be positive. But with that, then we can see there are 3 desserts. With ice cream and fruit. So 3 desserts that would have both. So that's a way you could use the addition rule to solve for a piece of the equation.